whatever you are gonna speak or anything, it will be recorded. So you know the attendance procedure also. So it is better you can start giving your attendance by putting your USN or name in a chat box. That's how we are taking the attendance. In the next class onwards, we'll be sharing one link of Excel file where you will be giving your attendance there. Okay, right now, for today's class, we will just give your attendance by putting your USN on the chat box. That will be considered as your attendance. And don't give the proxy attendance of your friends. It will be easy to track who has given whose attendance. Yeah, thank you. So here I'll start sharing my screen so that we'll start off with our today's topic. Yeah, I hope screen is getting shared. Just tell me whether you people are able to see my screen so that I can start.
Yes, sir.
Yeah, thank you. Sorry. So let's start with today's session. I think we have discussed about introduction of data structure, where we have seen about primitive data structure, non-primitive data structure. Then we have discussed about, if I'm not wrong, some of the data structure, just like maybe I think we started with the arrays, right? Let me start from here. If I'm not wrong, I think we have started with arrays. Yeah, we have talked about the arrays. Yes, guys.
Yes, sir. We are.
So we have talked about array accessing using loop also. Did we?
Yes,
Yeah, I think we have talked about these
Yes, sir.
examples. Okay. Okay, so I think we have discussed about the two-dimensional arrays also. Then we'll be discussing today about okay, we have come up with the list. We have taken about this. Yeah, stack. So basically, so can anyone tell me once again revise the concept of list? Yes, guys. List. More precisely, linked list. There's a concept of called as a node. What you will be calling it as a node? What node consists of?
Information.
Basically, node consists of two fields, beta. These are the two fields. If the screen is getting shared, this is a node where it has divided into two parts. This is the first part, triple A, and this is the another part. Okay. So what basically node is? Yeah, what did my node? What is a node of? I'll start with the Jambo. That will be easy for people. Students, this is what your a node which has an information field and a pointer field. It has two fields. A node has two fields. One is the information, that is your data, where the data or the information is going to be stored. Another is a pointer field. This pointer is pointing to the memory address of the next node which is going to access, which is going to connect. So such a small nodes are going to be linked together. They are going to be linked together. That's why this list is called the linked list. Linked list. This is what very simple concept. Linking the list, how the list will be created a small nodes, compiling them in a one way, that is not simply linking the list part. Okay, let me check whether the Jamboard is will start will be starting with the Jamboard. That is very simple to use. Okay, now in this I'll explain you the complete concept of the linked list. This is this Jamboard is also called as a whiteboard. Okay, as in online classes we don't have the whiteboard to explain, so we will be taking an help of Jamboards or any whiteboard online applications. So this is helping us to explain the concept in more detail, just like your classroom teaching. Okay, so let it. Okay, let me take the pen. Okay, class. Now let us assume this is your node. Okay, which has two fields. Okay, which has two fields. Uh, Let me draw once again about. Okay, fine. I'll draw another one. There is some internet issue. It seems it is difficult to connect. Okay, let it be. We'll be seeing about here. Now, in this linked list, what is going to happen? This is a node. I'll be drawing a node. Okay. Now this node is having two fields. Okay, let us assume it is a rectangular. I'm very bad in drawing. Sorry. Okay. This field is called as an information field. I'll rename it as this field is called as an information field. Okay. This is information field. Sorry, I don't have the mouse also here. Okay. This is my information field. And this is a pointer field. This field is a pointer field. You can call this as a pointer field. Now this pointer field is going to hold the address of the next variable, address of the next node. I can say this is my pointer field which is going to store address of the next variable, because this is a node. And how the link or list is being created, this is one node. Let us assume there is another node. This is at some different memory location. Okay, let us assume this is another node. Okay, now there is another node. This is also another node. Let it be its size, it doesn't matter कि इसको कितना भी बना दीजिए. चलिए ये मेरा, this is my third node. Let us assume I'm considering the another node, four nodes. This is my fourth node. Okay. Okay, this is my fourth node. Now what I am doing? Let us assume I have here value I'm considering here is my 10. Okay. This is value 2. This is, it holds the value 4. Okay. This holds the value, let us assume 1. Okay, this holds the value 2. Now let us assume, guys, I'm considering the memory address for this is 2000. I don't think I'll make a text box, that is better. I put this is 2000. Okay, the memory address for this is okay, fine. And in this fashion, the memory address of this is 3000. These nodes are situated at different memory locations in the memory. Okay, in the same fashion, if I'm considering this node is at memory location, let us assume it is at 1040. Okay, these are this one is at some memory location. You give any memory location, let us assume 2030. Okay, now these are holding some values. Let's assume it is holding some value. Let me get option. It holds the value 5. Okay, it is not showing. It's some problem. Anyways, technical problem will be always there. Okay, fine. Let us assume it is going to store some 21 values. Okay. Now plus, if I ask you, if I want to link them, say I want to ask you some question. Now if I want to plug them, whether they will be considered as whether they are in linear way, means whether the storing of them is at same memory location maybe, or the next location, the value or this node is stored at the next location. If you see, they are the scattered one memory address, one that's 10th value, this value is stored at the memory location 2000. The second value, which is going to be 2, is it is situated at the 3000 memory location. In the same way, this memory address is 2030. If I want to access all them, maybe in some different way, any fashion, doesn't matter. Is it a linear one? Is it a scatter one? Because they are the scattered one. They are stored in the memory, but they are scattered. Some of the elements are stored at some different place. So if I want to do access them, it will be very difficult, right? So in that way, how you have to do this? So what you will be doing, you will be making one link. You will be making one link, just like maybe if you want to access this element first, and the second element if you want to access, let us assume I want to access this, okay, 21. How will you do that? You need to link it. कैसे link करोगे आप? After this I want to access this element, okay, this element. How will you do that? After this location, that is 2000, after accessing the memory location 2000, you need to access the element which is stored at 2030. How will you do that? You will be giving one link. This is what the link, so that after accessing this, it will going through this. Who is taking care of this? This is nothing but the pointer. What pointer is going to do? Pointer is going to hold the memory address of the next element that can be accessed. It stores the memory address of the next element that can be accessed. So what it is going to store here, guys? Tell me. This is a pointer field. What it is going to store?
2030.
What value it is going to store? 20.
30.
30.
It is the address of that. What is the address? Address is 2030. Yeah. So this is the so this pointer is going to store the, okay, I need to access this. Okay, fine. Once I come here, now this is the second field. I need to access after this. Let us assume I need to access this element. Okay. So what I'll be doing? I'll be again making a one link from this. What is the information field? Information field has 21. Now it has to access the another. So I'll be making a one link from here. I'll be going to this memory location. So what is this memory location now? It is going to hold. It is going to hold the 3000
3000.
at the pointer field. So what we'll be doing? We'll be making, yeah, very good. It is 3000. So here it will be, you can add it as a 3000. That is your memory location. Very good. Now after this, if I wanted to access, this is what the 1040. So after this, I'll be simply making once again a link from this point to this. I'm making a link. Okay. Now what will be the address over here? What I'll be storing?
1040.
The address of the next
1040.
node that has to be accessed. So very good. It is 1040. So I'll be simply putting up here the value of the or address of the next variable or next element which I have to access. Now point number, and it is very important. Now after this, do I need to access anybody? I think all the elements are being accessed. Yes or no? So 10 is accessed, element 2, 21 is accessed, element 3, 2 is accessed, element 4 is been accessed. Now, what is the next element that I need to access here? Guys, is there anybody left out to be accessed?
No, sir.
Yes, sir.
Is there anyone which is left out to be accessed? No. Then what we will be doing in that case, it is called as a null pointer. Null pointer in the sense we are not going to access anybody. So it is generally represented as X. So this info pointer field is considered as cross. It means it is not going to access any element. It means the pointer is having zero. Zero in the sense it is not going to point any other elements. Point means it is not going to store any other elements address, because this is a pointer field. Pointer will always store the address, okay, of the pointer. Okay, it stores the address. Okay, so it will have this. Now I hope you understood a node. Now what happens, these are the four different nodes. Okay, now we are linking them. Yes, this is why it is called the linked list. It forms the list of how many elements? List of four elements. Which are those? Those are 10, 21, 2, and 4. How they were stored in a scattered way. Some elements were here, some elements were some at different location. Now if, please try to understand, this is very very important. Let us assume there is a one thread. Okay, if I start pulling it out, okay, if I start pulling it out, just usko खींच रहा हूँ, okay, whether they are able to easily access, say 2000, as it is the first node, I can easily access 2000. Then as per the rule, this is an integer. Okay, so this will be stored from the 2000 to 2003. The next element should be 2004, that has to be accessed, which is at memory location to 2004. Am I interested in 2004, 2005? No, it will directly say, okay, if you have accessed this, now move to the 2013. So here it comes. So after 2000 you will be accessing 2030. Then after accessing 2030 to 2033, it will directly move to the 1040. Then you, after 1040, you will be accessing 22 value. Okay, after that 1040, you will be accessing different memory location, right? So even though they initially they feel like they were scattered, but you have joined them, all different nodes, you have joined them and make it linear. Now, if you find, isn't it a linear one, linear linked list? Just check it out. Even though they are the scattered one, because the definition of a linear, what you have seen in a arrays, all the elements were stored in a continuous memory location. Is it a continuous memory location, guys? Is it a continuous memory location? Please tell me.
No, sir.
Is it is not. The first element is stored from the 2000 to 2003. Second element is storing from the 2030 to 2033. Third element is stored from 3000 to 3003. Fourth element is stored from the 1040 to 1043. Okay, it is not the continuous memory allocation, just like in array, but still it is a linear linked list, linear one, because we made them a linear. We have made one thread which is linking all those different scattered elements, scattered nodes, and we can just, we have connected them using the link, we are calling them as a pointer. So when I start accessing each and every element, let us assume here, after this it will directly move to the 2030. It is not going to access 2004, 2004, 2005, directly jumps to a memory location 2030. In the same fashion, now it gives you the feeling of having a linear. Okay, so this is called as a linear linked list. It is a list. Why? Because it has a four elements. It's a listing में एक से ज़्यादा elements होता है. This is what the list, right? It is a listing, but it is a linked list. It has a node. How many nodes it has? Four nodes it has. They are linked. That's why it's called linked list. Okay, and most of the people, they got confused whether it is linear or non-linear, because the linear, they know the concept that in the linear they should be in continuous memory allocations. If you have seen it, it feels it is not a continuous, but actually as we have given the pointer to them, you will feel yes, they are the linear one, they are the linear one. Okay, class. Hope you understood the concept of linear linked list. This is just an introduction. In the module 3, we will be discussing a lot of different flavors of the linked list. In module 2 also, there is as how we are going to design a stack and queue using the linked list. There also we will be discussing about it. For initial classes, this much knowledge is required to understand the linked list, and it is not only single. This is called a singular linked list. because we have only one pointer field. It may have, if you go through more depth of this, you will understand there is a doubly linked list. This is called a singular linked list. In doubly linked list, what is going to happen in doubly linked list? There will be two pointer. Now the problem is with this pointer, it is pointing to the next element only. In the doubly linked list, as it has 2 pointers, just like this. Okay, this is your info field. This is your info where you will be storing the data, your info. Okay, this is your info field. This is your previous pointer, and this is your next pointer. Generally we used to call it the next pointer, the element which is situated or which are going to be accessed next to that element. Okay, this is next pointer and this is previous pointer. It is pointing to the previous elements. Okay, that is how to access that, how it going to help us to implement lot of other application we will be seeing in the coming days. So this much is the basic ID linked list. Is there any doubt, guys? So that if there is no doubt, we'll proceed with the further things. Yes, class. Is there any doubt?
No, sir.
Thank you. Okay. Okay, so these are the different types. We'll be discussing one by one each and every part. I think we have discussed about this example, so giving an example of linked list. Now let's come back to the stack. Okay. Now stack means I think a plates keeping one above the other, or you can say the books keeping one above the other. These are called as a stack. Okay. Now if I give you one example of this stack, I don't know. Let's see here. Mm, if I take this is one example that I'll be giving you people. Uh, yeah, I hope this is visible to you. Yeah, this is visible. This is a one. Let us assume this is a I'm going to store. Now this is the first element which have stored. Okay, this is first element. This is my second element which I'm going to keep on this thing. Okay, in the same fashion I'll be taking my third element. Let us assume. Okay, this is my two elements are stored. This is my third element which I'm going to store. So how many elements we have? We have stored 3 elements in a structure. It might be like it is we will be calling it as a some different data structure for timing in some structure. Okay, I have stored it. Now if I wanted to take out the element, which one will be the element that I'll be taking out first? Just keep in mind, the niche wala end is closed, the bottom end is closed. We have only one end that is open. Okay, so which element is my power bank? The second element is my power bank. The second element I'm keeping in my container is my mobile phone. Third element I'm going to keep it in my speaker. So which is the first element which is going to be removed from this?
Speaker.
Speaker.
Speaker. Yeah, it is the speaker because we have only one end which can through which we can do the insertion as well as deletion. This is nothing but the deletion from the storage, right? Insertion into the storage, insert into the storage, delete from the storage, right? The second element that I'm going to delete from the storage, I'm using the word delete. Okay, that terminology is going to be changed in the next few minutes. The second element that I'm going to remove is what? Is my mobile
Mobile.
phone. Okay,
Mobile
because
phone.
now in this is the topmost element. right? This is the topmost element, so I'll be removing it. Now the last one, which is the topmost element, this is my power bank, it will be removing. Okay, now is there anything left out
No, sir.
to remove? Nothing, right? Nothing. So what happens here? First, once again, tell check these things, complete scenario. Because if you understand this, the Q concept, it will be easy to understand. Once again, it was empty. See, I'm putting now this insertion is called as a push. Insertion into the container is called as a push. Now I'm pushing the element. Now the element which is being pushed first, okay, this is the second element, and this is the last element. Last element which is pushed, it will be pop. Deletion we will be calling it as a popping. Insertion into the storage will be called as a push. Deletion from the storage we will be calling it as a pop. Okay. Now ये जो सबसे आखिरी में, this is the element which is being pushed at the last, it is going to be popped first. So in the another word, I must say last in, first
First out.
out. Yes or no? Last
Yes, sir.
last
Yes.
in. This is the element which is inserted last. It is the same element which is going to be popped out first. Last in, first out. Or this is the second element which is going to be popped out, and this is the first element which is coming out ekdam lastly. So first in, last out.
Last out.
It has a two approach. The meaning is same. If people used to confuse you people, okay, it is called as a last in first out. जो लास्ट में आया है वो फर्स्ट निकलेगा, या फिर फर्स्ट इन लास्ट आउट.
Last out.
First in, last out. This is how the complete stack is based. The complete stack is based on all these basic terminologies. We will be calling that operation is a push operation. While if we want to remove the element from this container, the stack, we will be calling that terminology as a popping the element, or push and pop. Pushing is inserting into the stack. Pop is deleting or removing the element from the stack. These two terminology we will be using in throughout when we will be discussing about the stack. Is that clear, guys? I'll be moving further. Okay. It is a non-primitive data structure, and yeah, I'll ask you by using this concept. I'll come back. By using this concept, can you tell me whether it is a linear or non-linear?
It's a linear.
This is a
Linear.
linear one or non-linear one?
Linear it is.
Linear.
May I know why? How can you say this is a linear or non-linear? Yes, somebody please put their efforts to explain me why it is linear, why it is not non-linear. Yeah,
Because we are arranging it one by one.
correct. See, in the arrays also, what we'll be doing, we'll create a memory locations. We'll create the first memory. First element हमने दे दिया. This is our memory location. We'll be putting without any space, without vestige of memory location. We'll be putting the another element in the array. Let us assume just like an array. Okay, and this is my third element. अगर आपको इस तरह से नहीं दिखता, इस तरह से समझिए. Okay, in the vertical way. Just try to understand. This is a of 0, a of 1, a of 2. Isn't it looks like your array? An array is a linear one. I think this much explanation is quite enough to understand the linearity of stack. Right, guys? I'll take you to the next slide. Yeah. Okay. It has this is a representation of a stack. Okay. Here you will be seeing here one end is completely closed while another end we are doing both the operation in the sense there are two operations while we discuss about the stack.
Insertion and
Those are your
deletion.
push and pop. Sorry.
Insertion and deletion.
And any problem? Any problem? Okay, fine.
No,
Okay.
sir.
Yeah, I'm sorry. Today I'm taking class actually from home, so there is a little bit problem with the internet at my place. So people, please manage. Okay. So in this stack, you will be the lower end is completely closed. We will be doing the operation from one end only. So both operation, that is push operation and the pop operation, will be doing from the single end. So this is how we'll be representing the stack. So insertion of element into stack is called a push, while deletion of element from stack is called as a pop. Okay. So generally, this implementation of the stack is done with two ways. Using the arrays, as I mentioned, arrays we can do as well as pointer. Pointer in the sense we will be using a linked list. Dynamic implementation will be seen. Okay, so we'll be discussing thoroughly about the stack in the upcoming module, that is your module number 2. Okay, in this we'll be starting with the queue now. In this module we'll be just discussing a small idea introduction, that's it. Okay, you might have seen or you might have heard about the word queue. Generally क्या होता है, what do you mean by queue? When I say this word queue, what you understand from the queue? Yeah guys, please tell me. What do you mean by queue?
Arrangement of elements in single line.
No, have you seen queue in your daily life, in daily routine life, I can say.
Standing in lines and all.
Yeah, that's what. Uh, Everywhere you go, there will be a queue. Just like your maybe you might be going for banks, you might be going for waiting for at the bus station. There will be queue.
Sir, like
People has to stand
entry
in a
and
line.
exit.
Maybe yeah, entry and exit. Yeah, so that's what the queue. Now, what different? That might be the question, right? Generally, it happens if you want to get into the bus in the last year. You have seen you used to be in a queue, and one by one, people will be get into the buses, right? That was a queue. That queue and this queue, what we will be studying in this subject, is it the same or different? My dear students, these are the same. These are not different at any moment. This will be the same. Here also we will be going in a queue. We'll be seeing every element will be accessed in queue only. The first element which have come first, it will be served first. That's what happens, right? It is called as a first in, first out mechanism. What happens in the stack? In the stack we have seen the people stack last in first out, the element which have come last used to serve first, or the element which accessed first served at the last. Okay, we have seen that. But in this queue, the person, let's assume this, the person which is standing first will get a chance to get into the bus very first moment. Okay, this is the first person who will be getting the chance to get into the bus first, and so on. Okay, that is what the queue. So Q is definitely, it's a linear data structure. If you are able to see in this example, so it's a linear data structure. After this, this is the element. It should not happen. After this, okay, this is the element, then this like that. It is not. It is in a sequential manner. So it is a linear element. Now what happens here? I'll tell you now. This is in this there are the two pointers in the stack we have seen. There was only one pointer. In Q there are the two pointers because reason is here both the ends are open. I'll tell you the example here. Now this person can move from here. At the same time another person can join. After this lady another person can join. So to get hold of this there is a one pointer. And ये बंदा बस में गया है क्या नहीं, whether this fellow get into the bus or not, to check that we require one pointer. So basically during the implementation of the queue we require two pointers. Those are called as a for rear and front your pointers. Okay, so here I'll give the definition or the implementation or the say introduction about this two pointers of the queue. Okay, so here in queue new elements are added to the queue from one end called as a rear end. So the insertion of the element is called as a rear end, and the elements that are removed from the other end is called as a front end. Okay, let us assume I'll tell you now. This is what front and rear. The elements. This is the first element which has come first. 10. So here the pointer is front. The elements which are coming joining later, this is called as a rear pointer. Okay, so this is rear pointer, which is where the elements are going to be inserted. Now if any other elements has to be inserted, it should be coming from this. So after 50, 60, or whatever the next element will be there, it will be added here. So it requires two pointer. Whereas when we discuss about the stack, as in the stack, the bottom end was closed. Bottom end was closed. Only the top end was open. So we have used only one pointer, named it as top pointer. Here, as the both ends are open, this end is also open, this end is also open. So we will be calling it as it is both the ends are open. So we require two pointers named as front and rear. Okay. The implementation again the same implementation what we are going to do in the stack using the static way, that is your arrays, and another is your dynamic implementation that is using the linked list. Okay, guys, any doubts in the queue, whether you understand front and rear pointer? I think there might be doubts in the front and rear pointer. Please ask me if you have. Okay, fine. We'll be seeing about the trees. Okay, yeah, trees is a data structure. Okay, what happens at the trees, guys? Because I wanted to know from you people what do you mean by trees. I need general dictionary meaning. Okay, I don't need the technical. Those who have learned the subject, fine, they can speak up. But those who don't have any idea about the technical terms of the trees, I want them to speak up. I want to see what they know about the tree. I'm very happy if you're going to tell me about a real life tree, because the meaning of the tree, why the name has given trees to this, it should be known to you people first. Please tell me about the trees. Come on, nobody has any idea about the tree. I think there are almost 38 to 39 students are present. 44 students are there. Nobody is having any idea about the trees they are seeing every day, and they don't have any knowledge about the trees. Come on. Okay, plus, fine then. It is very difficult in that case if you don't like trees. Trees, matlab kya? What you see in the trees, there will be branches, right? Trees will have branches. That's what I'm expecting. That's what I want. It should have branches. We should have two. Okay. There are the certain roots, leaves. I was expecting that. Anyways, fine. So what we will be seeing in this, this is what your trees, which has defined as a finite set of data items. Again, nodes. It is a non-linear. This is the first non-linear data structure. Prior to that, we have seen all the linear data structure. This is the first non-linear data structure that we'll be seeing. But the question is why it is called a non-linear data structure. We'll see. Okay. Now, in trees, there is a special data item at the top of hierarchy called as a root of the tree. Okay. The elements which are at the top, it is called as a root. Okay. The remaining data items are partitioned into number of mutually exclusive subset, each of which it itself a tree, which is called as subtree. The tree always grows in a length towards the bottom. It won't go towards the just like your tree moves to the apical, but we'll be seeing in downward direction. Okay, okay. This is what a tree structure looks now. This is an example of a tree that we'll be seeing in the upcoming classes. The A is the first element. Above this there is no element, so we will be calling the root. एक्चुअल ट्री में क्या होता है रूट नीचे होता है as I mentioned we'll be seeing from downward direction. Okay, so this is the first root and these are the different sub trees we can say sub. Okay, this is the node, this is the first node, we'll be calling it root node. These are the different nodes. It has a leaves also, these are called as the leaves. Okay, these are the non-leaves. These are there are these some other terminologies also we'll be discussing in the coming days. Okay, this is one of the example. One by one I'll be explaining thoroughly about this in the next class. So I think that is enough for the day. It will be 12:41. Okay, fine. Here I'll come. Uh, Guys, if you have any doubts related with that, please tell me. And please try to join the meeting before the time whatever given or plus 2 or 3 minutes. Once I start my recording I will never ever will be allowing the students who will be joining it late. Okay, because it is going to be disturbed for my class. And anyways, the recording whatever I'll be doing is it will be available on the YouTube channel of JCE Connect, so you people can take advantage of that also. Uh, I hope you people understood the basics. In the next class onwards, as we'll be seeing the graph, introduction of the graph, we'll be starting the depth of arrays. So I request you people, as well as inform others, those who couldn't be the part of today's session, to revise the concept of arrays, what they have learned in C programming, the basic operations that has to be performed on arrays, they have to go through that. Lot of the operation that has to be performed on arrays. If they have not knowing about this, it will be very difficult for every student to be able to understand everybody to understand the concept. It may happen that I may go forward, you may be at kept at left alone, so it should not happen. Okay? So that's for the day. I hope everybody has given the attendance. Uh, Take care, guys. If you have any doubts, keep asking. Okay. Thank you, plus thank you.